If you need to pass GED math but are feeling lost, stuck, and not even sure where to begin with your studying, know that I made this video for you. Now, even if you've been studying for some time now, if you're not where you want to be and you're struggling, sometimes what it takes to move ahead is going back to review some basic skills. And I'm going to cover a lot of basic skills in this video that are very important, and we're going to get started right now. So let's start off by talking about place values. So I just included this slide here to just give a basic review of place values. And we see here that 1 is in the millions place, 9 is in the hundred thousands place, 8 is in the 10,000s place, this 3 is in the thousands place, 4 is in the hundreds place, 6 is in the tens place, and 2 is in the ones place. Now we see here that this 1 is in the tenths place, this 3 is in the hundredths place, and this 4 is in the thousandths place. And now we're going to look at an example here, and this example will help you test whether or not you're understanding place values. And if you have any trouble with this, don't worry, because these questions are just put in here to help you learn. So all we care about right now is the learning. So don't worry if you get it right or wrong. And the first example that I want to talk about says, which digit from the following number corresponds to the given place value? And I filled in the first one here just to give you an example of how to complete the question. So let me give you a chance now to pause the video, take all the time you need, and whenever you're ready, just unpause the video and we'll go over the answer. Okay, so in this case here, starting at the 2, so this 2 here is in the tenths place. So if we come down here, you should have a 2 filled in here in the tenths place. And we see next this 1 here is in the ones place. Okay, so that's why I have a 1 filled in here. And the 8 here is in the tens place. And the 7 is in the hundreds place. And we know here that this 5 is in the thousands place. All right, so here are the correct answers. If you got this right, great job. If you didn't get this right, great job for trying. And we're going to move on to the next topic here. So now we're going to talk about rounding. And the first example that we're going to cover says, to the nearest 10, what is 942? Now, when we're practicing here, I don't want you to feel any pressure to get these questions right, okay? So obviously when you go in to take the real test, getting questions right matters, and we want you to get as many questions right as possible when you go in to take the real test. But right now when we're practicing, okay, I don't want you to feel any pressure to get these questions right. I just want you to focus on the learning right now. So throughout this video, just remember that all we care about is the learning, so don't worry if you get these right or wrong. And let me give you a chance now to pause the video, try this question out, and if you get stuck, don't worry about it because we're just going to go over it. Okay, let's go over this. So the first step here is to identify the number in the tens place. So 2 is in the ones place, 4 is in the tens place, and 9 is in the hundreds place. So I want to look at the number in the tens place, which is 4. And now what I'm going to do is look at the number directly to the right of it. Now, if the number directly to the right of it is less than 5, I'm going to round down. And if the number to the right of the 4 is a 5 or greater, I'm going to round up. So I see that I've got a 2. So since 2 is less than 5, I'm going to round down. So what does that mean? Well, I'm going to rewrite this and I'm going to leave the 9 unchanged. I'm not going to change the 9. So I'm going to write 9, 4, and instead of writing the 2, I'm going to just put a 0 here. Okay, so when I have 942 and I round it to the nearest 10, the answer is 940. The next example says, to the nearest tenth, what is 838.59? So let me give you a chance now if you'd like to pause the video, give this a shot, and whenever you're ready, we'll go over the answer. Okay, so what's my first step here? Well, my first step is to identify the number in the tenths place. And here, 5 is in the tenths place. And I don't want to get this confused with the tens place, right? So the number in the tens place is 3. But the question is asking me to round to the nearest tenth. So I need to start by finding the number in the tenths place, which again is the 5 here. So the next step is to look at the number directly to the right of the 5. And I want to ask myself, is this number something less than 5, or is it a 5 or greater? Well, since it's 9, all right, we see that it's a 5 or greater. Again, it's a 9, so I'm going to round up. So I'm going to come back to this 5, and I'm going to bump it up 1, and I'm going to make it a 6. And then the spot where the 9 was, I'm going to replace it with a 0. So let me show you what I mean. So this 838, I'm just going to leave it like it was. I'm not going to make any changes. So I have 838.6, and that's my final answer. So one last point I want to make here. Let's say that we want to round to the nearest tenth, and we know that 5 is in the tens place. And let's say that instead of a 9 here, let's say that this was something less than 2. Like let's say that this was a 3, for example. So if this number was something less than 5, that would mean that we round down. And to round down, all you would do is you would leave the 5 exactly like it is. And this would just be the answer, 838.5. And you could write a 0 here. It doesn't really matter. It's the same number whether you put the 0 or not. But anyway, I just want to make the point here again that if this number here was a 5 or greater, we would round up. And if it's something smaller than 5, we'd round down. So if you're not 100% sure you understand rounding and you want to get some more practice with rounding questions, what I'll do is I'll put 2 links down below in the description to videos where I cover examples on rounding. And if you want to, you can watch those videos too. And now we're going to move on to the next topic. So the next question says, please write the following numbers in order from least to greatest. And the numbers are 8,923, 8,933, 55, 9, 2, and 458. So now's your chance if you'd like to pause the video, try to figure this out, take all the time you need, and whenever you're ready, we'll go over the answer. So let's talk about this question here. So remember, we want to go from least to greatest. And let's start by comparing numbers that have the same number of digits. All right, so basically 9 and 2, these are both 1-digit numbers. And we know just if we count up, if we start at 1 and we count to 9, we know that we're going to get to 2 first. So we know that 2 is smaller than 9. Okay, and now let me look here. We see that we've got one number with 2 digits and we've got another number with 3 digits. So 3 digits beats 2 digits, so I'm going to write 55 next. All right, so a number with only 2 digits, again, is going to be smaller than a number with 3 digits. So I'm going to write 55 here. So now we've got one number that has 3 digits, this 458, and we've got 2 numbers that both have 4 digits. So again, I'm going to put 458 here because it's a smaller number than the numbers that have 4 digits. So now what we really want to do is we want to decide which number is bigger, 8,923 or 8,933. And I wanted to pull this over to the right a little bit, but it's going to mess the question up. So I'm not going to do that. So what we want to think about here is that if we start from left to right here, we see that both numbers have 8s in the thousands place, and they both have 9s in the hundreds place. So we're going to go to the tens place, and we see that the tens place breaks the tie here, because we see that 8,933 is a 3 in the tens place, and we see that 8,923 only has a 2 in the tens place. So 8,933 is a bigger number. All right, so in correct order from least to greatest, we'd have 2, 9, 55, 458, and then we'd have 8,923, and then finally we'd have 8,933. So just 2 things I want you to remember here. So first of all, like we saw here in this example, numbers that have more digits are going to be bigger. And whenever you have a tie, so whenever you're comparing numbers that have the same number of digits, just go left to right like I showed you here. Now, one more thing I want to say here is that if you're able to just look at a question like this and just kind of tell which numbers are smallest and which numbers are biggest just kind of by looking at it, that's great too, and that'll actually save you some time. I'm excited to announce that this video's champion shoutout goes out to a test taker who passed recently and finished all of the GED sections and is moving on to a career in cybersecurity, which is awesome. So right now as you watch this video, maybe your goal is to work in cybersecurity or maybe your goal is something completely different, but whatever it happens to be, just know that if you keep persevering and you keep working hard and keep working smart, someday you'll be done too and you'll have your own success story. So now we're going to talk about addition without using a calculator. And the example on screen says add 99 plus 82 plus 222. So let me give you a chance now if you'd like to pause the video, try this out without a calculator, and then whenever you're done, whether you get it right or not, don't worry about it because we're just going to go over the answer. So just unpause whenever you're done and we'll talk about it. Okay, so let's talk about addition without a calculator. So when I see a question like this, the first thing that I like to do is rewrite it so that the numbers are stacked on top of each other. And it will take just a little bit of extra time to do this, but I think it's easier to see this way. And it's up to you to decide if you want to do this on your test or not, but I think it's easier this way. So this is how I like to teach it. And what we're going to do first is add the numbers in the ones column. So here we can see this is the ones column, this is our tens column, and this is our hundreds column. So what is 9 plus 2? 9 plus 2 is 11. What is 11 plus 2? 11 plus 2 is 13. So what I'm going to do is I'm going to stick my 3 down here, and I'm going to put the 1 up here. And then when I add the tens column, I'm also going to make sure to consider the 1 here. Now, in other words, I'm going to carry the 1, I'm going to regroup the 1, several different ways of saying the same thing, but here's what it all boils down to. I'm going to start by doing 1 plus 9. 1 plus 9 is 10. Then I'm going to do 10 plus 8. 10 plus 8 is 18. Then I'm going to do 18 plus 2. 18 plus 2 is 20. So I'm going to put my 0 down here, and now what I'm going to do is regroup or carry that 2. So I'm just going to stick the 2 right here. So now I come to the hundreds column, and I add up my hundreds column. I do 2 plus 2, and 2 plus 2 is 4. So the answer here is 403. The next example says add 89 plus 32. Please answer without using a calculator. So now's your chance if you'd like to pause the video, try to figure this out, take all the time you need, and whenever you're ready, we'll go over the answer. Okay, so when I teach these questions, I always like to start by rewriting the numbers so that they're stacked on top of each other. So that's what I'm doing here. And then what I'm going to do is start by adding the numbers in the ones column. So what is 9 plus 2? 9 plus 2 is 11, so I'm going to put a 1 here, and I'm going to carry the 1, so I put a 1 up here as well. So now I'm going to do 1 plus 8. 1 plus 8 is 9. Now I'm going to do 9 plus 3. 9 plus 3 is 12. So I'm going to put a 2 here, and I actually don't have anything here in my hundreds column, so I'm just going to stick the 1 down here, and the correct answer is 121. So now we're going to switch gears and talk about subtraction. And the first example says, what is the difference between 54 and 37? Please answer without using a calculator. Is it A, B, C, or D? So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, just unpause the video and we'll go over it. So the first thing I'm going to do here is rewrite the numbers so that they're stacked on top of each other. And now what I'm going to do is start by subtracting the numbers in the ones column. But the thing to see here, and this is really the key to getting this right, is that 4 is a smaller number than 7. So in order to subtract here, what I'm going to have to do is borrow. So I'm going to come over here to my 5, and I'm going to cross the 5 out, and I'm going to change it into a 4. And then I'm going to stick a 1 in front of this 4, and it becomes a 14. So now I'm going to do 14 minus 7. 14 minus 7 is 7. So now let me subtract the tens column. So what is 4 minus 3? 4 minus 3 is 1. So the correct answer here is B, 17. So the next question says 1 minus negative 4 equals what? Is the answer A, B, C, or D? And I'd like you to try this one without a calculator. So if you want to give it a shot, please go ahead and pause the video, take all the time you need, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so the first point that I want you to understand here is that subtraction tells us to go to the left on the number line. So let's say that we had something like this, I don't know, maybe 5 minus 3. So let's say that we have 5 minus 3. So one way to think about this is that imagine we had a little stick figure person on 5. So if we had a little stick figure person on 5, and we know that subtraction tells us to go to the left on the number line, so 5 minus 3, the stick figure person would go to the left 3. So the person would go 1, 2, 3, and the stick figure person would end up on 2. So we know that 5 minus 3 equals 2. Now, you probably knew how to do 5 minus 3 without using a number line, but I just wanted to start by giving us a foundation here so that we understand that subtraction tells us to go left on the number line. Okay, so the next point that I want to make here is that negative numbers tell us the opposite. Okay, so in this case here, for 1 minus negative 4, let's start with our stick figure person on 1. And in this case, remember, negatives tell us the opposite, so we want to start at 1 and take away negative 4. So since the negative means to do the opposite, instead of going left 4, we're going to go to the right 4. So our stick figure person starting at 1 is going to go 1, 2, 3, 4 different steps. All right, and the stick figure person ends up at 5. And the correct answer here is 5. Okay, so I wanted to just show you on the number line how you can think through these questions here. But one key point that I want you to understand here is that subtracting a negative is the same as adding a positive. So in other words, minus a negative is the same as plus. All right, so whenever you see something like this, 1 minus negative 4, you can just remember that subtracting a negative is the same as adding a positive. So when you see 1 minus negative 4, you can really just change this into 1 plus 4. All right, minus a negative is the same as plus, minus a negative is the same as plus, minus a negative is the same as plus. You're probably getting annoyed that I keep repeating that, but I just want to make the point here that, a faster way to remember how to answer these questions is whenever you see minus a negative, you can just change it into a plus sign. So 1 minus negative 4 is the same as 1 plus 4, which is 5. So remember, subtracting a negative is the same as adding a positive. Another way to think about that is that minus a negative is the same as plus. So the next example is negative 5 plus 9 is the answer A, B, C, or D. And I'd like you to try this without using a calculator. So let me give you a chance now if you'd like to pause the video, try this one out, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so since we have the number line here, let's think through this using the number line. So I want to start by putting my stick figure on negative 5. So here's my little stick figure person on negative 5, and addition, or a plus, tells us to go to the right. So here we're going to go to the right 9 steps. All right, so the stick figure person, imagine, is going to start on negative 5 and take 9 steps. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's where the stick figure person ends up, and we see that 4 is the correct answer here. So C is the right answer. So the next question is negative 18 minus negative 11, and is it A, B, C, or D? So let me give you a chance now to try this out. Please answer without using a calculator. And whenever you're ready, you can just, you can pause the video, give it a shot, and then unpause the video, and we'll talk about the answer. Okay, so here there are a couple different ways to think about this. So one way to think about this is to remember that minus tells us to go left on the number line, and negative tells us the opposite. So in this case, minus negative 11, what I would really do here is I would start with negative 18 and I would go to the right 11 steps. Okay, so that's one way to think about this. Now, another different way to think about this that is going to give us the exact same result is to remember that minus a negative is the same as plus. So if I have negative 18 minus negative 11, since minus a negative is the same as plus, I can really just think of this as negative 18 plus 11. So remember, minus a negative is the same as plus. And if you think about it, you can kind of visualize that the stick figure person would start at negative 18 on the number line, and we know that plus means to go to the right. So the person would start at negative 18 and go to the right 11 spaces. Okay, so however you want to think about this, the answer here is A, negative 7. So the answer to negative 18 minus negative 11 is A. So I sent out a poll recently to my audience of GED test takers to ask them how helpful do you think memorizing multiplication tables is for GED math, and 88% said helpful and 12% said not helpful. So I would recommend memorizing your multiplication tables. Sorry if that's not what you want to hear, because I'm sure your time's probably limited as it is right now, but it wouldn't hurt to learn them. So when it comes to learning your multiplication tables, there are different ways to do it, and at the end of the day, you have to go with whatever you think is going to work best for you. But one way you can do it is by quizzing yourself and figuring out which ones you don't know, and then I recommend, for the sake of time, find the ones that you don't know and focus on memorizing those. And I type something like times tables quiz or something like that into Google, and this website, timestables.com, is one of the first results that came up, and there are, I'm sure, other resources out there that you can use that'll work just as well. This is just what popped up for me, and I'll put a link to this down below in the description if you want to use this site. But basically, you can just click on whichever times tables you want and quiz yourself. So for example, you could go to 2's times tables, and right here it shows you the answers, so try not to peek at these. But you could just go through all of these and try them, try to fill in the box for all of these, and then check your answers, and whichever ones you don't know, maybe write those down on a sheet of paper and just spend time reviewing the ones that you don't know. So now let's talk about multiplication. And the first example is, what is the product of 95 and 32? Please answer without using a calculator. So let me give you a chance now if you'd like to pause the video, try to figure this out, take all the time you need, and whenever you're ready, we'll go over the answer. Okay, so I'm going to start by writing the numbers on top of each other like this. And after I do that, the first thing that I'm going to do is do 2 times 5. So what is 2 times 5? Well, 2 times 5 is 10. So I'm going to put the 0 down here, and I'm going to put the 1 up here. Now, my next step is I'm going to do 2 times 9, and I'm going to add the 1. So 2 times 9 gives me 18, plus 1 gives me 19. So the first partial product is 190. And let me cross this one out so I don't get confused. So now the next thing I want to do is I'm going to put a 0 right here in the 1's place as my placeholder. And it's important to remember to do this. So now I'm going to start by doing 3 times 5. So 3 times 5 is 15. So I put a 5 here, and I put the 1 up here. So now I'm going to do 3 times 9. 3 times 9 is 27. 27 plus 1 is 28. So here's what I have now. I've got 2,850 as my second partial product. So now what I want to do is add the partial products, and that's going to give me my answer. So 0 plus 0 is just 0. 9 plus 5 is 14. So I put the 1 here. I'm sorry, not the 1. I put the 4 here. I'm going to put the 1 right up here. So now I'm going to do 1 plus 1 plus 8. So 1 plus 1 plus 8 gives me 10. So I'm going to put the 0 down here. I'm going to carry the 1. So now I'm going to do 1 plus 2, and my final answer is 3,040. So when all is said and done, C is the correct answer here. Okay, so the next question says, what is the product of 27 and 32? Please answer without using a calculator. Is the answer A, B, C, or what about D? So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so the first thing that I'm going to do here is stack the numbers on top of each other like this. So I'm going to do 27 and 32, and now I'm going to multiply them. So the first thing that I'm going to do is do 2 times 7. So 2 times 7 is 14. So I'm going to put the 4 down here and put the 1 up here. Now I want to do 2 times 2 and add the 1. 2 times 2 gives me 4, plus 1 gives me 5. So the first partial product is 54. Now I'm going to cross this 1 out so I don't get it confused. And the next step is to put a 0 down here as a placeholder, and that's very important to remember to do. And now what I want to do is 3 times 7, and 3 times 7 is 21. So I'm going to put a 1 down here, stick a 2 up here. So now I do 3 times 2, which is 6, plus 2, which is 8. So my second partial product is 810. So now I add the partial products up. So what is 4 plus 0? 4 plus 0 is 4. What is 5 plus 6? 5. I meant to say 5 plus 1 equals 6. So what is 5 plus 1? 5 plus 1 is 6. And now I have this 8 here that I could just pop down. So the answer is 864. So B is the correct answer here. So let's switch gears now and talk about division. And I'm going to cover a few examples of division here in this video. But if you feel like you want to see more examples after the ones I cover in this video, I'm going to put a link down below to one of my videos where I cover division and cover more examples, so you can watch that video. That would be one resource to check out for additional help on division. Then the second link down below I'm going to put is for Kate from Light and Salt Learning's channel. So Kate from Light and Salt Learning, she did a video about the division algorithm, and it's a really, really helpful video to help you learn how to beat division questions. And if you've never watched Light and Salt Learning before, Kate has a lot of really great videos on a lot of different topics for the GED test, so I'd also recommend her channel in general. But anyway, I'll put those two links down below in the description. And the first question here that I want to cover is 34 divided by 2. Now, I'd like you to try doing this without a calculator, and I've also put the 2's times tables over here for you to reference if you'd like to, and I put these here because we're just practicing. On the test, these won't be given to you, so you'll want to know them. Let me give you a chance now to pause the video and try this out, and if you get stuck or just have no idea how to do it, no worries, because we're just going to go over it. Okay, 34 divided by 2, how do we break this down? Well, the first thing that I want to think about is how many times does 2 go into 3? Well, I see here that 2 times 1 is 2, so I'm going to start by just putting a 1 right here directly above the 3. So 2 times 1 is 2, so I'm going to write a 2 right here. So now what I do is I'm going to subtract. So 3 minus 2 equals 1. So now I'm going to just pull the 4 down here. So I pull the 4 down here and I have 14. So how many times does 2 go into 14? Well, 2 times 7 is 14. So I'm going to put a 7 right up here. So 2 times 7 is 14. So I'm going to write 14 down here now, and I'm going to subtract. And I see that 14 minus 14 is 0. So I don't have any remainders, and the answer is just 17. So the next question is 320 divided by 6. I'd like you to try this without a calculator. And I've also given you the 6 times tables over here. And this is, since we're just practicing right now, if you want to reference the 6 times tables throughout this question, you can for right now since we're just practicing. But on the test, you won't be provided these. You'll want to know these. So let me give you a chance now if you'd like to pause the video, try this out. And if you get stuck or just have no idea how to do it, no worries, because we're just going to go over the answer. Okay, 320 divided by 6. Let's talk about it. So the first question I want to ask is, how many times does 6 go into 3? Well, 6 doesn't go into 3. So what I'm going to do is put a little x up here above the 3. And this x is not going to be part of the final answer. I'm just putting this x here so that I know that the next number that I write up here is going to go above the 2. And in Kate from Light and Salt Learning's video on division, she uses this trick. She pushed the x here. And like I said, I'll put a link to that video down below. So 6 doesn't go into 3. So the next thing I want to ask is, how many times does 6 go into 32? So we come over here and we see that 6 times 5 equals 30. So I want to pick 5 here. Now I don't want to pick 6 because 6 times 6 is 36. That's too big. So I'm going to go with 5 here because 6 times 5 gives us 30, which is something close to 32, but it's not bigger than 32. So I want to put a 5 right here, and notice again that I'm putting the 5 directly above the 2. So what is 6 times 5? Well, we know 6 times 5 is 30, so I'm going to write 30 here. Now the next step is to do a subtraction, and of course they're using some kind of power tools outside of my window again. I don't know if that's going to show up on the recording, but if it does, I apologize in advance. So 3 minus 3 is 0, 2 minus 0 is 2. So now I want to take this 0 here and pop the 0 down here. So I put a 0 down here. Now I want to ask, how many times does 6 go into 20? So I know that 6 times 3 is 18, so I'm going to want to roll with the 3 here. So I'm going to put a 3 up here. Now, why don't I want to pick 4 here? Well, 6 times 4 gives us 24, which is bigger than 20, so that's not what we want. We want to go with 3 because 6 times 3 gives us 18, which is close to 20, but it's not bigger than 20. So again, we put the 3 up here. So now I do 6 times 3, which gives me 18, and I write the 18 here. So now I want to subtract. So 20 minus 18 is 2. So I see that I've got a remainder 2. So all I'm going to do is I'm going to put an R here and put a 2 here, and that tells me that there's remainder 2. So the correct answer here is 53 remainder 2. So now let's talk about multiplying and dividing negative numbers. And the first example in this series that I want to cover is negative 8 divided by 4. And getting the sign correct in the answer here is really the key to getting the question right. So I'd like you to try doing this without a calculator, and let me give you a chance now to pause the video, try this out, and whenever you're ready, we'll go over the answer. So the key to getting this right is remembering that a negative divided by a positive gives us a negative number. Okay, so remember, a negative divided by a positive gives us a negative. So we can really just cross out B and C because we know that the answer, it can't be a positive number. All right, and this is the same for multiplication, right? If you take a negative number and multiply it by a positive number, the answer has to be a negative number. All right, so here, negative 8 divided by 4 is negative 2. So A is the correct answer. But the key here, the most important point that I want you to take away from this example is that a negative divided by a positive gives you a negative, and the same is true for multiplication. A negative multiplied by a positive gives you a negative. So the next example is negative 18 times 4. Is the answer A, B, C, or D? So please try this without using a calculator. So let me give you a chance now to pause the video, try this out, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so the first thing that I like to do for questions like this is to stack the numbers on top of each other like this. But the second most important thing to do in this case, in my opinion, is to think about in advance, is the answer going to be a positive or a negative number? All right, and since we've got a negative number multiplied by a positive number, we know that the answer is going to be a negative number. So I'm going to do two things here. So I'm going to cross out A and I'm going to cross out C. So what I'm also going to do is I'm just going to put a negative sign down here in my answer right away, so that way I don't forget it. So now let's do the math. So what is 4 times 8? 4 times 8 is 32. So I put the 2 down here, put the 3 up here. Now, what is 4 times 1? 4 times 1 is 4, plus 3 gets me 7. So the answer is negative 72. And remember, I already put this negative sign down here before I even did the math so I wouldn't forget. Because it would be a shame to, on your test, do a question like this and work it out by hand and say, well, 18 times 4 is 72, and circle A. And it is true that 18 times 4 is 72, but we're not doing 18 times 4, we're doing negative 18 times 4. All right, so that's why I always like to just think in advance what the sign's going to be, just to be safe. All right, and if you got this wrong or had any trouble with this or mixed the signs up, absolutely no worries. Right now, we're just practicing. So the next example, it's negative 12 times negative 5 times negative 4. Now, let me give you a chance to pause the video, try to figure this out. Please try it without a calculator, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so the first thing that I want to do here is to think through what the sign of the final answer is going to be. And this is very important because I hate to see someone go into the test and take all the time to calculate this out by hand, but make an error and get the right number, but the sign's wrong, and therefore they get the whole question wrong. So I don't want that to happen to you, and I don't want that to happen to anyone else. So that's why I'm taking time to make the point here that it helps to think about what the sign of the final answer is going to be before you do the calculation. So if I work left to right here, I'm going to do a negative number times a negative number, which is going to give me a positive number. Then I'm going to multiply that positive number times a negative number, which will give me a negative number. So let me slow down and say that again. So first, negative 12 times negative 5. All right, I'm multiplying two negative numbers together. That's going to result in a positive number. So a negative times a negative gives me a positive. It's the same with division. If I divide a negative number by another negative number, I'm going to get a positive. All right, so just keep that in mind here. And then what's going to happen after I do negative 12 times negative 5 and get that positive number, I'm going to multiply that by another negative number, and that means that my answer is going to be negative. So right off the bat, I can cancel out both C and D because I know that the final answer is going to have a negative sign. So let's do the math here. So what is negative 12 times negative 5? Well, that's going to be positive 60. So one way to do that would be to remember the 12's times tables, but you could also work it out by hand and you would get 60 that way too. That's a perfectly fine way to do it. So now we're going to do 60 times negative 4. So one way to do this would be to write it out by hand and do it like this, which is a perfectly valid way to do it. And if you did it that way, you would do 4 times 0, which is 0, and then you do 4 times 6, which is 24. And remember, it's going to be negative because it's really negative 4 times 60. So that's one way to get the answer. However you get there, the answer is A, negative 240. So hopefully this makes sense. So now let's talk about exponents. So what we see here on the screen is 4 squared. We could also call this 4 raised to the second power, and we could also call it 4 raised to the power of 2. Multiple ways of saying the same thing. So if I gave you this question, 4 squared, and I said, what does 4 squared equal? What would you say? Well, sometimes what test takers will do here is they'll see a question like this, and they'll think that they have to do 4 times 2 to solve it. And this is actually not how we want to do the question. So if you thought that the way to solve this is by doing 4 times 2, know that you're not alone. This is actually a common mistake. And I want to cross it out here so we know that it's a mistake here. And again, if you made this mistake, absolutely no worries for right now because all we care about is the learning. And I'm just pointing this out because I want you to succeed on your test. And if you get something that involves exponents, I just want you to know how to do it so you can maximize your score. And how we want to do this is instead of doing 4 times 2, what we really want to do is 4 times 4. And the reason why we do this is because the exponent tells us how many times the base appears in multiplication. Let me say that again. The exponent tells us how many times the base appears in multiplication. And 4 is our base and 2 is our exponent. So I can look at this and I can know that we're going to do 4 times 4. And 4 times 4 equals 16. So here's another example. This is 4 raised to the power of 3. We could also call this 4 cubed. So let me give you a chance now to pause the video and without using the calculator, try to figure this out if you'd like to. So now's your chance to try it now. Okay, so let's talk about this question. So what I don't want to do is do 4 times 3. Okay, so I don't want to do 4 times 3 here. What I really want to do is 4 times 4 times 4. So 4 times 4 is 16. So I know that for multiplying the first two 4s, we'll get 16. Now, off the top of my head, I don't know what 16 times 4 is, so I'm going to write it out like this. I'm going to stack them on top of each other like this. So 4 times 6 is 24. So I'm going to put the 4 down here. I'm going to put the 2 up here. And I'm going to do 4 times 1, which is 4. And I'm going to add 2, which gives me 6. So the answer here is 64. So 4 raised to the power of 3 equals 64. Let's try another example. So here's another example, and this one's a little bit harder. 6 to the power of 5. So without using a calculator, I'd like you to pause the video, try to figure this out. If you get stuck, don't worry about it because we're just going to go over it. So let me give you a chance to try this now. Okay, so there are a couple different ways to work your way through this, but the thing that we don't want to do right off the bat is we don't want to do 6 times 5. What we really want to do is 6 times 6 times 6 times 6 times 6. So we should have 5 6s here. Okay, so this is the part where I guess you could think through this a couple different ways, but what I'm going to do is I'm going to look at it like this. So I know that 6 times 6 is 36. So the first two 6s, if I multiply them together, I'll get 36. And I know that if I multiply these two 6s together, I'll get 36. So what I'm going to do here is I'm going to do 36 times 36. All right, and again, you could approach this a different way and you would get the same answer. But this is just how I'm doing this, so I'm going to do 36 times 36. What we want to do here is start by doing 6 times 6, which is 36. So I'll put a 6 down here, put a little 3 up here. So now I'm going to do 6 times 3, which is 18. And I'm going to add 3 to it, which gets us to 21. So I'm going to put a 0 down here as a placeholder. I'm going to cross out this 3 so I don't get it confused. So now what I'm going to do is 3 times 6, which is 18. So I'm going to put an 8 right here, and I'm going to put a 1 up here. So now I'm going to do 3 times 3, which is 9, plus 1 is 10. Okay, so I've got my two partial products. So what do I want to do next? The next thing I want to do is add here. So 6 plus 0 is 6, 1 plus 8 is 9, 2 plus 0 is 2, and I'm just going to bring my 1 down here. So I have 1,296. So now what I can do is rewrite this whole question as 1,296 times 6. All right, so again, let me just back up here and recap what I did. So I just saw that I had 6 times 6 times 6 times 6 times 6. So again, I saw that the first two 6s here, if I did 6 times 6, I got 36. And I knew that if I did this 6 times this 6, I'd also get 36. So I did 36 times 36, which got me 1,296. Then this last 6 right here, what I'm about to do, is multiply this 6 by 1,296. And again, you could have looked at this. There are different ways to work your way through this, but they're all going to give you the same answer. So 6 times 6 is 36. So I put a 6 here, put a 3 up here. 6 times 9 is 54. So I'll put I have to add 3 to it. So 6 times 9 is 54 plus 3 gets me 57. So I'll put a 7 down here, put the 5 up here. 6 times 2 is 12. 12 plus 5 is 17. So I'll put a 7 here, put a 1 up here. Now 6 times 1 is 6, plus 1 is 7. The answer here is 7,776. So great job if you got this right. This is not an easy question. And if you didn't get this right, great job for trying. Hopefully this makes sense. I was going to ask Tommy if he had any math tips he wanted to add here, but he was too busy playing video games and I didn't want to interrupt him. So here's something that you should know. Any number raised to the power of 0 just equals 1. So I'm going to write the basic rule here. So let's say any number raised to the power of 0 it just equals 1. So we can pick any numbers at random. Let me just say 52. So 52 raised to the power of 0, we know that that would equal 1. Let's try 500, right? So it doesn't matter, any random number, just pick it out, and if you raise it to the power of 0, it equals 1. I don't care if you use, let's say 29. 29 raised to the power of 0 equals 1. So you should know that if you raise any number to the power of 0, it just equals 1. Okay, so let me back up here, and something else you should know is that any number raised to the power of 1 just gives you that number. So if I take a and raise it to the power of 1, I just get a. All right, so I don't know, let me pick something at random. Let's say 32. 32 raised to the power of 1 is just 32. We could also do 63 raised to the power of 1. Doesn't really matter. I'm just making up numbers at random here just to show you that that would be 63. You know, you could do 26 raised to the power of 1. It doesn't really matter. Anything raised to the power of 1 just gets you that same number. Okay. So hopefully these two cases are clear here. So now what I want to teach you is how we deal with a scenario where two numbers have the same bases and we are multiplying those numbers. So let's say we have something like this: a raised to the power of b times a raised to the power of c. Well, whenever we multiply two numbers that have the same base, it's the same as adding the exponents. So in other words, a raised to the power of b times a raised to the power of c is the same as a raised to the b plus c. So let's go over an example now, and the example says a raised to the power of 5 times a raised to the power of 4 is equal to which of the following? Is the answer here A, B, C, or D? So let me give you a chance now, if you'd like to pause the video, try to figure this out, take all the time you need, and if you get stuck, don't worry about it because we're just going to go over the answer. Okay, so what I see here is that we've got two numbers. We've got our a's here. So the bases are the same here. So what we can do is add the exponents. So a to the power of 5 times a to the power of 4. Since the bases are the same, we can add the exponents. So this is the same as a raised to the 5 plus 4. All right, and what is 5 plus 4? 5 plus 4 is 9. So when all is said and done, we see that a raised to the power of 5 times a raised to the power of 4 is the same as a raised to the power of 9. So B is the correct answer. So now let me talk about what happens when you divide two numbers that have the same bases. So let's just make something up here. Let's say a to the power of, I don't know, let's just go with B again. So a raised to the power of B over a raised to the power of C. So how would I deal with this? Well, a raised to the power of b over a raised to the power of c, that's the same as a raised to the b minus c. So when you have two numbers that have the same base and you're dividing them, all you have to do is just subtract the exponents, just like you see here. All right, so let me show you an example now, and it actually, okay, it covered up the rule. So here's the rule right here: a raised to the power of b divided by a raised to the power of c is equal to a raised to the b minus c. All right, so hopefully this makes sense. So let me get rid of this here, get this out of the way here so I can fit the question on screen, because here's the example that I wanted to go over. So here's the example. It's a raised to the power of 10 divided by a raised to the power of 6. Is this equal to A, B, C, or D? So let me turn it over to you now. I'll let you pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so basically the rule here is that when we are dividing two numbers that have the same base, it's the same as subtracting the exponents. So a to the 10 over a to the 6 is the same as a raised to the 10 minus 6. Okay, and 10 minus 6 is 4. So when all is said and done, the answer here is a raised to the power of 4. So C is the correct answer here. So here's another exponent rule to know. And this one is that whenever I have a base raised to a negative exponent, I can rewrite it as 1 over that same base, but with the same exponent, but the exponent's positive. So let me give you a practice example now, and I'd like you to practice this one without using your calculator. And the example is 5 raised to the negative 2. Does it equal A, B, C, or D? So let me give you a chance now if you'd like to pause the video, try to figure this out, take all the time you need. And whenever you're ready, we'll go over the answer. Okay, so if I have 5 raised to the negative 2, I know that I can rewrite this as 1, this is supposed to be an equal sign, as 1 over 5 raised to the positive 2. So I know that 5 raised to the power of 2 is the same as 25. So I can say that 5 raised to the negative 2 is the same as 1 over 25. So C is the correct answer. So now I want to talk about raising a number with an exponent to another exponent. So let's say we had something like this, a to the power of b raised to the power of c. So how would we deal with this? Well, all we have to do here is just multiply the exponents. So this is the same as a raised to the b times c. So let me bring an example up on screen here, and the example that I want to talk about is 3 raised to the power of 3 raised to the power of 2. So without using a calculator, I'd like you to pause the video, give this one a shot. 3 raised to the power of 3 raised to the power of 2, is it equal to A, B, C, or D? And if you get stuck or aren't sure how to do it, don't worry about it because we're just going to go over the answer. So let me give you a chance now to pause the video, try this out, and whenever you're ready, we'll talk about it. Okay, so what we're going to do here is we're going to start by multiplying the exponents. So 3 raised to the power of 3 raised to the power of 2, we can turn that into 3 raised to the power of 6 because 3 times 2 is 6. So we start by multiplying the exponents. So now how do we solve 3 raised to the power of 6? How do we figure out what that equals? Well, what we don't want to do is we don't want to do 3 times 6, right? What we really want to do is do 3 times 3 times 3 times 3 times 3 times 3. So now we're just going to work through this, and you could work through this in a couple ways that would get you the same answer. What I see here is that 3 times 3 is 9. Okay. And I know that 9 times 3 is 27. So actually, if I look at these first 3 3's here, I know that 3 times 3 times 3 is 27. And again, the reason why I saw that is because I know that 3 times 3 is 9, and then I know that 9 times 3 would be 27. All right, so these first 3 3's here, if I multiply them together, I get 27. And I can say the same for these 3 3's over here too. 3 times 3 times 3 is 27. So to finish this out, what I can do is 27 times 27. So let me line them up on top of each other, and hopefully I'm going to have room here to do this. And again, like I said, you could potentially work through this. You could look at this. There are different ways to look at this, 3 times 3 times 3 times 3 times 3. But all roads should lead to the same answer here. As I try to work through this here, this is just how I'm working through it here. So what is 7 times 7? 7 times 7 is 49. So I'll put a 9 down here, put a 4 up here. And I want to be careful that I don't run out of room here, but anyway, 7 times 2 is 14, plus 4 is 18. So my first partial product is 189. So I want to put a 0 right here as our placeholder, and I'm going to come up here and cross this 4 out so I don't get it confused. Now what I want to do is 2 times 7. Now 2 times 7 is 14. So I put the 4 here, put a 1 up here. Now I want to do 2 times 2, which is 4, plus 1, which is 5. Okay, so we're almost done here. We just want to add our partial products together here. So 9 plus 0 is 9. 8 plus 4 is 12. So I'll put the 2 down here, bring the 1 up here. Now I want to do 1 plus 1 plus 5, which is 7. Okay, so the correct answer here should be 729. C is the right answer here. So in some of my longer videos, I include a segment called Champion Facts where I just pop out from behind the screen and I answer a few this or that style questions, and I do this just to give you a break from thinking so hard and also to try to make the video a little bit more fun. And I know that math can be pretty boring, so that's kind of why I do this, and I actually get a lot of positive feedback on these segments. But if you think I'm just wasting your time and you don't want me to do this in the future, let me know down below in the comments. And anyway, the first question I have today is tacos or burritos? And this could go either way for me. I would really take either, but I'm going to go tacos today. And it looks like a slight majority agreed with me. Okay, washing the dishes or vacuuming? For me, I'm going to go with washing the dishes. And actually, most people it looked like on this quiz said vacuuming, which is interesting. Roller coaster or Ferris wheel? I'm going to take roller coaster. Okay, 67% to 33%. Watermelon or strawberries? For me, I'm going watermelon. So now let's talk about square roots. And what I have here is a list of common square roots. And I typed this list out, and I'm screenshotting this list from one of my other videos where I cover square roots. Then I also wrote the square root of 25 on here because for some reason I forgot to type it out in this list, so I just wrote that in by hand. But I would recommend memorizing this list of common square roots here. It's only going to help you if you memorize it. And one thing that I want to stress here is that if I have a number and I square it, and then I take the square root, it gets me back to that original number. So let me show you what I mean. So let's say I've got 5 squared and 5 is my base. All right, so 5 squared is equal to 25. So if I take the square root of 25, what happens? Well, it gets me back to 5. All right, so let me show you one more example here just to make this point. So let's say that I start off with 9 and I square it. So what is 9 squared? Well, 9 squared is 81. So then what happens if I take the square root of 81? What does that get me? Well, the square root of 81 is equal to 9. So as we practice our square roots throughout this video here, I'm going to leave this list on the screen and you can reference it as much as you need to, but just know that this list won't be provided for your test. So since we're just practicing, I'm going to give it to you now, but it won't be provided on your test. So now let's just look at an example here, and the example says the square root of 79 is a number between, is it A, B, C, or D? So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so the idea here is that if I look over here at the numbers underneath the square root symbols, what I see is that 79 would be between 64 and 81. So the square root of 79, I don't know exactly what number it is, but I'm going to assume that it's something between 8 and 9, because 79 is a number between 64 and 81. So the correct answer here is C. It's going to be a number between 8 and 9. So that's kind of how I'd reason my way through this. If x squared equals 36, what is the value of x? Again, if x squared equals 36, what's x? So let me give you a chance now, if you'd like to pause the video, try to figure out what x equals, and then whenever you're ready, just unpause the video and we'll talk about it. So a common mistake here would be to think that in order to get x, you have to square 36. So if this is what you thought you had to do, absolutely no worries, because this is a really, really common mistake that a lot of test takers make. But what you actually have to do is take the square root. So if you ever see a scenario like this, what I want you to remember is that to get x, we don't want to square this. What we really want to do is take the square root. Okay, so let me show you what happens. So if we take the square root of x squared, that gives us x, which is what we want. And whatever I do to one side, I also have to do it to the other. So if I take the square root of x squared, I also have to take the square root of 36. And the square root of 36 is 6. So just to kind of cover all of our bases, just in case this pops up on your test, I wouldn't expect this to be very important, but I just want to put this up here just because you never know. So whenever you see a base raised to the half power, or the power of half, however you want to say it, that's the same as the square root of that base. So 14 raised to the half is the same as the square root of 14. Okay, so let me just show you another example here. So if I ever gave you something like this, 7 raised to the half, that's the same as the square root of 7. Okay, so like I said, I wouldn't expect this to be super important for your test. I don't think it will be, but I just kind of want to show you this just to cover all of our bases. Okay, so your next example is on the screen here. Is this equal to A, B, C, or D? So let me give you a chance now, if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so here we have 4 raised to the power of 3 over 2. And the first thing I'm going to do here is I'm going to rewrite this. So we see that we've got a 2 in the denominator of our fraction. So what we can do is we can rewrite this under the square root. So we can rewrite 4 raised to the 3 over 2 as the square root of 4 raised to the power of 3. Okay. So what is 4 raised to the power of 3? Well, 4 raised to the power of 3, that's the same as 4 times 4 times 4. So here there's two different ways to look at this. So the first would be to just do 4 times 4 times 4. Now off the top of my head, I know that 4 times 4 equals 16, but I'm not sure what 16 times 4 is just off the top of my head. So let me work that out here. So 6 times 4 is 24, and then I put a 2 up here, and then I do 4. Barely looks like a 2. Here's a 2. So I do 4 times 1, which is 4, plus the 2 gives me 6. I think I worked this out earlier in the video, this situation where we had 4 times 16. But anyway, 4 times 16 is 64. So the square root of 4 times 4 times 4 is the same as the square root of 64. Now we know over here from our list that the square root of 64 equals 8. Okay, so that's one way to get the answer. So the other way to look at this would be to get to this step right here, right, where you have the square root of 4 times 4 times 4, and to say, hey, the square root of 4 is 2. So the square root of 4 times 4 times 4, I could just make this 2 times 2 times 2. And 2 times 2 times 2 is 8. Okay, so two ways of looking at this that would both get you the same answer. So here's an example for you to try. The square root of 16 plus the square root of 9, does it equal A, B, C, or D? And I'd like you to try this without using a calculator. And you can use this common square roots list if you need to, but just keep in mind that you'll have to know these by memory for the test. This won't be given to you. So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So what I would do here is I would just say, hey, the square root of 16 is 4, and the square root of 9 is 3. So I would just change this. Instead of having it as the square root of 16 plus the square root of 9, I would change it into 4 plus 3, and 4 plus 3 is 7. So B is the correct answer here.